Hello everyone. In this video, we're going to use change of base formula to determine the exact value of logarithmic expression, and this is the second part. Before we dive into these examples, let's have a review on the basics of logarithmic equations. We remember that we can change logarithmic equation to its equivalent exponential form following this general rule that we have here. So if we are given log of m to the base b equals k, this can be changed into its equivalent exponential form. B to the power k is equal to m. To better understand this rule that we have here, let's have example equations involving integer values of x. So let's take this first example right here. So we have log of 64 to the base 4 is equal to x. So to better understand this, we're going to rewrite this into its exponential form. So this would come out 4 to the power x is equal to 64. So we need to figure out how many times should we multiply 4 such that we get 64, or what should be the exponent of 4 to make it to 64. So the value for x here is 3. That means if we multiply 4 3 times, 4 times 4 times 4, that will give us 64. In the next example right here, we have log base 2 of x is equal to 3. Again, we can change this to its equivalent exponential form. This would come out 2 to the power 3 is equal to x. This means that we are going to multiply 2 3 times. 2 times 2 times 2, that would be the value for x. And so the value for this would be 8. So in this equation that we have up there, our x value is 8. In the last example that we have here, log of 81 to the base x is equal to 2. We can change this to its equivalent exponential form. X squared is equal to 81. So we need to figure out what number should we square, or we multiply by itself twice. It gives us 81. So that value of x is 9. That means 9 squared, or 9 times 9 is 81. Going back to this slide right here, if we are given log of p to the base k, using the change of base formula, we can actually rewrite this as log of p over log of k. So I'm just going to write that down here. Now, please remember that if there is no base to this logarithmic expression, that invisible base is 10. However, we can actually assign any base to both the numerator and the denominator, and it doesn't matter. So if I write b here as our base, I can also come up with another b here as the base for the denominator. So we are going to use this change of base formula that we have here in order that we can evaluate these expressions that we have right here. So let's take this first example. Log base 8 of 32. Using the change of base formula, we can go ahead and rewrite this as, that's going to be log of 32 over log of 8. Now, we are going to determine what should be the base for this. You can pick any number. However, we can say that our base here would be 2 because both 32 and 8 are divisible by 2. So I'm just going to write here 2 for both of them. So that if we are going to simplify this, we are going to ask ourselves, what is the exponent of 2 such that it is 32? So that value here is 5, which means that if we change this to exponential form, 2 raised to the power 5 is 32. Now we move on to the denominator here. So the question that we're going to ask would be, what should be the exponent of 2 such that our value is 8? So that would be 2 to the power 3 is actually 8. So then this is the exact value of log of 32 to the base 8. At this time, I would encourage you to pause this video and try these two problems out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So this log of 27 to the base 81 can be rewritten as log of 27 over log of 81. So we're going to determine what should be the base for this that would work for 27 and 81. So both of these are divisible by 3. So we can go ahead and write 3 as their basis. So then we are going to ask ourselves, what should be the exponent of 3 such that it becomes 27? So that would be 3 to the power 3. So that's 3 to the power 3 is equal to 27. And then we have the other one right here on the denominator. What should be the exponent of 3 such that it gives 81? So that value would be 4, which means if we have 3 raised to the power 4 is equal to 81. So this is the exact value for log base 81 of 27. Now let's move on to the last one right here. So this log of 125 to the base 25 can be rewritten using the change of base formula as log of 125, that's over log of 25. So we need to figure out the base for both of these. So these 125 and 25 here are both divisible by 5. So that we can go ahead and write 5 as their basis so that we are going to determine what is that value. 5 raised to the power blank is 125. So that would be 5 raised to the power 3 is 125. And then 5 raised to the power blank is 25. And that should be 2. And that makes sense because if we have 5 raised to the power 3 is 125. 5 raised to the power 2 is 25. So this is the exact value for log of 125 to the base 25. Did you get the same answers as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!